Hello, everyone. Hello, students. Welcome to study physics, and I hope you will discover this lesson with me. And thank you for your appreciation to visit. Let us start Unit 2. This is physics for grade 9 for Ethiopian students, which says motion in a straight line. The contents of this unit is uniform motion, uniformly accelerated motions, and the graphs of uniformly accelerated motions, equations of uniformly accelerated motions, and relative velocities. So, uniform motion. When it comes to uniform motion, what's motion first? When we say uniform motion, there must be a definition. We have to know the definition of motions. So, what are motions? When we say something is moved or on motion, what does it mean? That means when motion is a change in position of an object with respect to its surrounding in a given interval of time. When an object changes its positions from one place to another within a given interval of a time, we call an object is on motion. So motion means change of positions of an object. When an object changes position, we call it is on motions. So what's uniform motion then? Uniform motion is a motion of an object moving at a steady speed in a straight line. Which means if an object move at constant speeds in a straight line, we call motion is uniform motion. So steady speed in a straight line means direction is also constant, speed is also constant. So we can say if an object is in a uniform motion, if the motion of an object is in uniform motion, a velocity remain constant. If velocity is remain constant, acceleration is zero. Dear students, don't forget that the term uniform means it's just like similar. So when we say uniform motion, the speeds of an object moving at the uniform motion is its speed is constant, which means its velocity is uniform. If there is no change of velocity, acceleration is also zero. You should have to remember this one. For example, a bus driving at steady 100 km per hour along a straight road. But if it is along a curved road, it won't be uniform motion. I think it is clear. Distance. Let's start from the definition. What's distance? How can we define distance? Distance is a physical quantity. Since we are studying physics, we all around physical quantities. So what's distance then? Distance is defined to be the magnitude or the size of displacement between two positions. Distance traveled is the total length of the path traveled between two positions. Don't forget that. Distance is a total path traveled between two positions. Let me explain this example later. Distance is scalar quantity. Since it's a physical quantities, it must has a units. So its unit is meter, and it is scalar quantity. It can be expressed. It only expressed in magnitude. There is no direction associated with distance. Distance is represented by S in equation. Example: a cyclist rides 3 kilometers and then turns around and rides 2 kilometers east. Then the distance traveled between these is 5 kilometers. Let me show you using my pen here. If a cyclist is moved to this direction, 3 kilometers, and let me use another one, and it's back to this 2 kilometers. Then let us this one is point A, and this one is point B, this one is point C. Then first the cyclist rides 3 kilometers from A to B and 2 kilometers from B to C. Look at the directions. But since you have said that distance is the total length, distance is the total length of path traveled between two positions. We have said that here. So distance should be from point A to C, which is 5 kilometer, which is 5 kilometer. So this is how we talk about distance. When we talk about distance, it's just look like this one. Okay, let me erase one. Okay. Then if the distance is just like one, what about displacement? Displacement, it's again from definition. Displacement is a change in position of an object. Same with distance, but there is additional term here. Displacement is distance moved in particular direction. The difference is here. Displacement, there must be particular directions. So from this we can understand that as a vector quantity. So we can say it's the shortest path between two positions. And it's a vector quantity, we have said that, and its unit is same as distance, which is meter, and it is represented in equation by bolt or with an arrow. Let us come to example 2.1 again. If let us use again our pointer. If the car moves, the cyclist moves 3 kilometers to the side, that indicate, and turns again and moves 2 kilometers here. We have said that one is point A, this one is B, and this one is C. Now displacement is distance from A to C only, which is this one. The displacement moved is only from this one, the shortest path from A to C. since we have said that it's the shortest path between two positions. So when we find 3 minus 2 is 1 kilometer in the west directions. That is why we say displacement is distance moved in particular direction here. Good. Dear students, I hope you have uh, got the concept of distance and displacement. You have got the concept of distance and displacement. So let you brainstorm with some interesting questions. What's the difference between distance and displacement? Please try to identify their difference with examples. Athletes running around circular track, if they complete 6 laps, with each lap being 1 kilometer, then what's their distance and displacement? Third question. A cyclist rides 5 kilometers west and then turns around to ride and rides 2 kilometers east. What's air displacement? What's distance she ride? A runner jogs 2 kilometers north, then turns 60 kilometers east. What's the distance and displacement of the runner? The last question involves Pythagoras theorem that you have discussed in Unit 1 under vector combination of perpendicular vectors. So please try to revise about vectors.